Yes, so I think the actual topic of the presentation will be a surprise to most of you because it's quite a generic title. This was a working title early on, but we kept it for some reason. But the real title is this: Result Analysis in OMNeT and Associated Best Practices, of course. So we've been occupied with improving result analysis since the 5.0 version. There are a lot of stuff done for the 5.0, 5.1 versions, and also the last year's summit was quite a milestone because we heard that we presented SQLite result 5 format, and at the panel discussion, Python and Pandas and the usefulness of Jupyter was mentioned, which made us look at these topics and how to use these tools for OMNeT result analysis. So basically, I give you the guts in the first slide, so you can sleep afterwards. So if you want to do casual plotting and just browsing at the simulation results, you can use the analysis tool in the IDE. But if you want to do anything serious, then we recommend that you use Python with the right packages. So there's a tutorial. We go into the second part using Python. So what is Python? It's it's a nice programming language which is getting a lot of hype today, and it's especially for usage for big data analysis, machine learning, AI, these kind of topics. But it can be used really for anything. It's generic. It's a general purpose programming language with lots of packages. Yes, just two slides to show how Python popularity has shoot up. This is statistics of Stack Overflow, like page views about Python-related issues. And it starts from 2012 and ends at 2018, 1718. It just goes up. And another graph, which compares it to existing languages. This one, the first one, was compared to like niche languages or newer languages like R, Swift, Scala. And the other, this is like comparing it to mainstream languages like JavaScript, Java, or C++. Okay, so there are first tools that we recommend that you look at when you work with Python. The first one is Jupyter Notebook, which has been mentioned quite a few times. It's basically a web application which and you can use it basically on the first level as a comfortable Python shell. You can enter commands, and then when you enter a command, it shows the output below. And you can organize this kind of thing into nice-looking documents, interactive documents. So it's good for experimentation, and it's also good for documenting the way you have worked. Okay, another one is Pandas. So this is pretty much the standard data analysis library for Python. It's essentially the port of GNU R's data frame, data structure into Python. It's on the basic level. It's just it's a very powerful table data structure. It provides indexing, so it's very high performance. And cells may contain arbitrary objects, so not only numbers and strings, but also any object. So, for example, arrays or matrices. And some key features are that you can query the contents of the table, you can update the table, you can filter rows and columns, you can join tables together, you can merge tables, you can do pivoting operations on it, you can do statistics on rows and columns and so on. So there's lots of functionality in there. And it can export data from CSV, JSON, Excel, HDF5, and many other formats. And it has a nice plotting capabilities because it integrates with the standard Python plotting package, matplotlib. So it's a short example. This is some code where you create a data frame. So there will be 3 columns, A, B, B, and CCC with some values. And some basic commands that you can try is describe. It will print statistical summary of all 3 columns, like mean, standard deviation, stuff like that. Or with this indexing syntax, you can choose a column, BBB column, and compute the mean of it. Or you can add up 2 columns, and that will be like element-wise additions of the 2 vectors, the 2 columns. Or this one is just to get the table in CSV format. There's, of course, a lot more. This is just a small intro. So there's also matplotlib that we want to use. It's modeled after MATLAB's plotting package. And it has both interactive and batch modes, so you can just use it just to save images and also to like zooming and panning and that kind of stuff. And it's capable of plotting 1,000 plot types. So, of course, line plots, scatter plots, bar charts, box plots, volume plots, everything you can think of. And you can also do custom plots because you have also access to the basic drawing API. And it has two programming interfaces. One is an object-oriented one, and there's another one built on top of it, which is more convenient to use. And it can work with Qt, GTK, and also you can supply custom backends. Okay, also some example where in the first 2 lines we fill one array for the range, some values on this range, compute values, and then simply plot them. Create a title and show the graph. Okay, and this is just a gallery for what kind of plots you can do with matplotlib. So really the possibilities are endless. So how do we use them together? The short answer is that there is a tutorial. I took this summer to write up most of this tutorial, and it's available at this web address. And of course, the tutorial itself was written using Jupyter, so it's also like a Jupyter notebook that you can try and execute. Yes, so you can find everything in this tutorial, and thank you for your attention. No. No, we go into some details because otherwise it will be too too short. So how do we get simulation writes scalar files and vector files. So we need to get this data into Python. How do we do that? You can go to the IDE and export the data in CSV or JSON. There are new exporters, new versions of the IDE. And in Python, you can use the read CSV function to read everything into a data frame. Okay, this is of course good for convenient use, but if you have to do it 100 times every day, go to the IDE, select the dialog, it becomes boring. So maybe you want to use Scave tool, where you can do some scripting. You don't have to click that much. Or a third way, actually we are going to use the second way in this tutorial. The third way, it's possible to write a specialized Python library for reading OMNeT result files into a data frame. And actually, we are in the process of writing such library. It's like 80% done. And it will be published, of course, then. So this eliminates the conversion step. And a completely different way, first 3 is equivalent, almost. The fourth way is to configure OMNeT to record SQLite result files. And the advantage is that you can use the power of SQLite select statements. So you can write quite complex select statements just to get the data out of the files you want. And one issue which is not easy to overcome is that if you run several simulation runs, they all write separate files, and it's difficult to join data from these separate files in one select query. So you can like record in one file, or afterwards merge the several SQLite files into one file and do the queries on that. We'll see how that works out. We have to get some experience in practice. And it would also be possible to change the result recording feature in OMNeT so that it records CSV files directly, which we can load into Python. This has not been tried, but it's certainly possible. Okay, so when we use Scave tool to export in CSV format, this is a sample of what you get. You can see that there are lots of columns, and the trick is that not all columns are used so there are several different row types, and not all columns are used for all row types. You can say that at the end of the lines there are lots of empty columns. So what do these rows mean? We have different line types, and the first two columns are the same for all line types. There is the run, identifier of the run, and the type. And there are types like scalar, vector, statistics, histogram, or attribute, like result attribute, iteration variable from the parameter study, run attribute, and parameter assignment. And for example, if we look at the vector, for the scalar, then we have, we run a type, and we have the name of the module which has recorded the scalar, the name of the statics, plus the value. And if we have a statistic, then of course a module name, and there are statistical summary fields like count, mean, standard deviation, that kind of thing. And for vectors, the two columns are the vector time and the vector value, which are like space-separated numbers. So we will read this into a long string. In pandas, we have to split it up into a vector of floating point numbers. Yes, how do we import that? There is a read CSV function, of course. And after that, or during reading, some conversion necessary. So the true false will be read as strings. We need to convert them to Python booleans. And also the numeric strings need to be converted into ND arrays. And it's possible to do it after the reading, but it's also possible to specify converters for the read CSV function. It will be done on the fly. It's shown in the tutorial how to do it. Okay, now some more details on pandas. Pandas basics. So you can select one column by specifying its name in square brackets, or there is also an abbreviation which works most of the time, not always, because some names are reserved or colliding with other uses. So this doesn't always work. You can select a subset of columns. So this looks scary because of double square brackets, but it's really a list of strings used as an index. And you can also filter rows. And here the trick is that you compare the column to a value, and this will result in a element-wise comparison. You will get an array of booleans, and when you index the data frame with an array of booleans, you get the rows where the true values are, and the false values will be filtered out. So this is the way you can filter by types or values or by any condition. Okay, we go into some more operations. One common thing you will need to do is pivot operation. So when we read in the file, we'll have, for the scalar values, we'll have the name in one column and the value in another column. But it's often more convenient to have separate columns for the different variables. So what we need to do is take the unique values from the name column, convert them to columns, and put the values underneath, matching it with the index column, the first column. So this can be done with this pivot operation. And often we have to apply another pivot operation. For example, this is the example from an Aloha. So here we have several simulation runs, and the values produced by each simulation run. But it's often more convenient to have a value like, okay, what's the like utilization for 15 hosts and interval mean 3. And for this you can apply another pivoting operation, pivot table, which is a little bit of variation on the previous one. This can also do aggregation. And here we specify mean as the aggregation function, which will result in the values that come out of several runs. They will be averaged. So if we have like 10 simulation runs for every num-host and IA mean pairs, then they will be averaged for here for the pivot table. Okay, what can we do with this table? The data frame has a plotting function. So if we take the output from the previous one and say plot.line, then you will get a nice line chart like this. So for different number of hosts and different traffic intensity, the channel utilization varies like that. Okay, how do we plot vectors? It's actually a lot more simple than plotting scalars, because we can just select a subset of vectors, loop through them, and for each row we'll have two columns. One column is line, one column is the time, which as a vector. Another is as a vector which contains the values. So we can just plot them using the matplotlib line plotting function. Okay, how do we plot histograms? Histogram data are basically in two columns. There is a bin edges column and there is a bin values column, and there's one more element in the bin edges array than in the bin values array. And we can just use also a line plot with a special drawing style to plot a step function, plot it as a step function, only we need to add an additional 0 element so that the histogram ends at the x-axis. Okay, that was about Python. And I'd like to tell you about an ongoing effort as well, because the IDE analysis, we'd like to improve the analysis tool in the IDE. This is pretty much work in progress. So why do we want it to improve? What's the motivation for that? So in the current analysis tool, one problem is that the computational power is limited because arbitrary computations cannot be expressed. Like, for example, if we have an output vector, one cannot compute a histogram from it because the graphical language built into the tool is not expressive enough. Also, charting options are limited. Only the most common chart types are supported. And also from the usability points of view, it also leaves something to be desired. It's some users find the user interface not so intuitive and struggle with it. And a third problem was that there's no transition path. So if you just do basic data exploration and the browsing and just casually create some charts, it's not easy to go from there and reuse it in Python scripts. If somebody goes from using the analysis tool to R or Python, they need to re-implement everything. So what do we want to have? We'd like to be able to express arbitrary computations in a concise way. We'd like more charting options, possibly unlimited charting options. And we would like smooth transition towards standalone script-based result analysis, so towards using Python. And of course, we want to still retain the ease of use for casual result exploration and plotting. Yes, simple things should be easy and complicated things should be possible. How do we do that? We scratch the data set based user interface and we just add simple charts, which are like icons, like in a file browser. And what happens when you double click on a chart? A new page opens and the chart is drawn. You can create a chart in the usual way, like selecting some vectors and hitting the plot button, or you can create a new one, create a blank one, and then configure it. And inside one chart, a script will live. And this script will be user editable, so you can change it and you can add custom processing steps and also like chart configuring or plotting customization steps in it. And still configurable via dialogues, so you will still be able to configure most of the chart properties via dialogues, so axis titles and stuff like that. And in this chart page can also contain like folders for grouping chart sheets also for grouping and showing them together, and standalone scripts which would be reusable across the other charts. So what do we want to use for scripting? Of course, Python. And that would give us great potential because it would boost the computation and plotting abilities of the IDE. And of course, it would provide a smooth migration path if you want to go for standalone Python data analysis. Okay, so when you create a chart, the initial script will be copied from a template, and it will, the names of the results will be like substituted into the template. And then, of course, you'll be able to edit the script and do whatever you want using pandas and matplotlib and whatever. And the script will have access to the data that is loaded into the analysis tool. So you can access the same scalars and same vectors and everything. And you can do the plotting via either matplotlib, or there will be also a possibility to instantiate the analysis tools built in chart types, because a lot more scalable than the Python ones. They have less features, but they are a lot more scalable. They're able to deal with a lot more data. So what do we use for technology? We use a Java Python bridge. It's Py4j. So the Python process executes in a separate process, and it will talk to the IDE via socket. And this has some few nice properties. Of course, there is some runtime overhead, but the advantages far outweigh the disadvantages. So if the Python process crashes for some reason, the IDE will not crash. And if the Python process manages to allocate too much memory and blows up and everything is out of memory, the IDE can just kill the Python process and the machine will survive. And it's also easier to abort long-running or runaway computations, because also we just kill the process from the IDE. Okay, we use the matplotlib custom backend. So basically, the Python process renders a pixmap, and we'll send the pixmap in a compressed form over to the IDE, and we show it in the IDE. And we have a proof of concept implementation, and it looks like it works quite nicely. So even though we are sending images via socket back to the IDE, it's still zooming and panning. This is still okay. So the delays and lags are still within acceptable. So like a few hundred milliseconds, it's well within tolerance. So it looks good, but this is also only a proof of concept. We need to work some more on it. And while we are there, we have done also a lot more UI improvements, redesigned inputs page, local toolbars, increased, decreased precision, that kind of stuff. So this is what the prototype UI looks like. Here you can see a Python script. This is some data selection. And here this is a plot creation using matplotlib. And here's the result. You can still use the mouse for zooming and panning and all that kind of stuff. So what is our immediate roadmap? 5.0 release will be done within a few weeks after the workshop, but it will not yet contain the new UI, but it will contain the tutorial and the exporters necessary to use the Python pandas functionality. And the enhanced analysis tool can be expected for OMNeT 5.3, which is like March next year. So this concludes my presentation, so thank you.
So, questions from the audience?
Yeah, thank you. I'm really looking forward to try this out. My current approach is basically having some regular expressions and parsing the Scala files. how would you compare this approach in terms of performance? So basically, then with your approach, I have to build up the whole pandas data frame with everything and then select. So how do you think the performance compares?
We didn't make detailed, like, very many performance tests, but our impressions I got is that it's going to be workable. And if you say that you have a lot of scalar files and huge scalar files and so on, and maybe it's not feasible to load everything into memory at once, and then the solution is that it's also possible to do filtering while reading the CSV file. It's in the tutorial, so you just filter out what you need, and you get a lot smaller scalar file, or you can, like, leave out the vectors, leave out the histograms, only the scalars, or leave in only data from specific modules, or only specific statistics and stuff like that.
Yeah, that sounds great. Thanks.
Additional questions regarding the best practices for result analysis. OMNeT questions, we save them for later. We still have time.
Yeah. Hello. So I'm very happy that data sets are going away, or in the sense that, yeah, as you said, the interface is not very obvious, at least to me. And second thing is, I use both Python and MATLAB. So, but since it's coming from you, why the emphasis on Python, other than the cost of MATLAB?
Well, question is more like, so there are like three contenders here, like R, MATLAB, and Python pandas. And basically, MATLAB is like, okay, R is for statistical computing, so it's more suited to our goals of analyzing simulation results. And MATLAB is general matrix, vector operations, and this kind of toolboxes. So it's not specialized for statistics, and it doesn't have the equivalent of the data frame. And I'm not very familiar with MATLAB. That also have the impression that it's not very good with structured data. So it's good with matrices and vectors, but not very good with highly structured data and string data and other and these types of things. And for Python, basically the momentum is behind Python. And I have tested, I'm very, very impressed with the performance of the pandas data frame. So the operations, even on huge data frames, non-trivial operations are quite fast. So there's lots of indexing and caching and reference counting, that kinds of magic going on in the background. It has very impressive performance. And it's growing really fast. And also, when you place your bets on Python, you have access to a general purpose programming language. So if you want to create, for example, a custom UI for your stuff, you can do it because there are GUI programming libraries in Python. If you want to put machine learning in it, there's no problem because there are machine learning libraries in there. So you have access really to everything.
So lots of nodding from the MATLAB users, so I guess your comments on MATLAB, everybody agrees. Another question before we close the session. That is not the case. No, not the case. So let's thank Andras again for the best practices.